Hi, this is Miss D, and these are the notes on motion in one dimension. We're going to set up a circle map, so you're going to want to go ahead and start drawing your circle. So motion in one dimension. So what does that really mean? So basically what we're going to be talking about is linear motion. So we're going to call this linear motion. So we're moving in a straight line. And in order to talk about linear motion, we need to have what's called a reference point. And a reference point is just a still point that you're going to use to compare whether or not you've moved. So it's compared to a moving object. If I'm in a car and I'm looking at a billboard, the billboard is my reference point. It's not moving. We also say that this is a frame of reference, and a frame of reference is a coordinate system like an X and a Y axis, an X and a Y axis that is used to describe or define a starting point and a stopping point of our motion. So I'm going to draw a little one here. So if I have my x-axis and my y-axis, for motion in one direction, I'm just moving on one direction, one dimension. So I would start and then I would finish just in a straight line. And so you could see I could measure on my graph or my coordinate system how far I've moved, and that would define my motion. So when I talk about how far I've moved, we refer to that as distance, and distance is just a measure of the length, and an example of a distance is 5 meters. And in this we have two things. You have a magnitude or a number, 5, and you have a unit. And here the units are meters. And this is referred to as a scalar quantity, and that's a word that we'll be using a lot. We also will sometimes talk about displacement, and displacement is different than distance. Displacement is the change in position of an object, and it's the distance an object has been moved from the beginning to the end. So from its initial location to the final location. So we're going to go ahead and we're going to have to calculate or solve for the displacement. So we solve for displacement, how far an object has been moved from the starting position to the end, using the formula below. I'm going to write it here for you. It's delta x equals xf minus xi. And that looks really confusing. That's where x is equal to the position. The delta means change. That little triangle is a delta. It means change. xf is the final position. So where did I end? xi is the initial position. Where did I start? So it's my ending point minus my starting point. And we're going to go ahead and we're going to look at a little example. So if I draw a little line, I have my starting point, I have my finish point. That purple line that I just drew is the distance. That's how far I traveled. But this white line connecting my starting point to my finish point, a straight line, that's my displacement. So I have my xf, my final, xi initial. So I have 5 meters southeast is an example of a displacement. I have a magnitude, I have a unit, and I have a direction. So I have a number, I have a unit, and I have a direction. Okay, and that is a displacement. And that is referred to, when I have a direction, that's a vector quantity. So you need to know that distance is no direction, and displacement does, in fact, include a direction. So let's look at an example problem. Okay, the Hulk is waiting around for Thor and Iron Man. He gets anxious and starts pacing back and forth. He's outside and there's nothing to smash. He jumps 10 meters to the east, punches the ground twice, and then jumps back to the west 4 meters. He shouts for 20 minutes, breaks a rock, and leaps 7 meters east. Find the Hulk's distance and displacement. So we're going to do that. Let's start by drawing a picture. So he's going to go ahead and, if you look at my picture, he jumps 10 meters to the east, he jumps back 4 meters to the west, and then he jumps 7 meters to the east. So if I want to go ahead and find the distance, which is the total amount that he's traveled, it's 10 to the east plus 4 to the west plus 7 to the east. and that's going to be a distance of 21 meters. If I wanted to find his displacement, I would have to go ahead and find the total distance he moved from start to finish. So it's going to be from the starting point to the ending point. So that's going to be 10 minus 4, because that was in the opposite direction, plus 7, which is going to give me a displacement of 13 meters to the east. And you can see that that he's not moving the total distance that he traveled, because he's kind of going back and forth. And that's the difference between distance and displacement. I hope that makes sense. If it doesn't, please feel free to come talk to me during class.